This is the third lecture of our example number 2, which is the design of beam. So students, in this example, we have to design for beam B18, 19 and 20. So in the last lecture, we have to completed our example up to the load on first of all beam B18 and beam B20, because you can see that in this figure your beam number B18 and beam B20 is the mirror image of one another. So first of all, in the last lecture, we have to find out the load on beam B18 and beam B20. So it is already discussed that there are four dead load. First one is self-weight of slab, floor finish, then masonry wall load and self-weight of beam rim. These four loads is to be considered while we have to design for the beam. And after that we have to find out the load on beam B19. So students, whenever there is the design of beam B18, 19 and 20, the first step is to find out the load on all the respective beams which you have to design. So in the last lecture we have to find out this load combination. So at the end of the lecture we have to conclude our example up to this slide, in which whenever this is the plan of the figure and this is the elevation. So you can see that you have to see this figure from this side. So this is your first beam, which is beam B18, B19 and 20. So the length of beam 18 is 6 meter, 19 is 4 meter and 20 is 6 meter. Okay, so students, for first span your UDL is 50.75 kilonewton per meter. For B19 it is 46.82 kilonewton per meter, and for beam B20 it is 50.75 kilonewton per meter, which is calculated in the last lecture. So students, now there is different methods. So first of all, there is two types of main beams, determinate beam and second one is indeterminate beam, which is you have to already studied in your semester 4 and semester 5. So in semester 4 the subject name is structural analysis 1. In semester 5 the subject is structural analysis 2. There is two types of beam, determinate beam and indeterminate beam. In that semester there is lots of method like Macaulay's methods, load deflection methods. One method is not in your syllabus, the name is Kani's method, moment distribution method. So all this method, but the most precise method is the moment distribution method. Okay, so in this example, whenever you have to design for beam, you have to refer the moment distribution method. So for moment distribution method, your first step is to find out FEM. It means fix and moment. So our step is fix and moment. Now this end is fixed. This end is also fixed, because your beam column joint, your beam column junctions is always a fixed support if you have to not give release on that point. Okay, so this is your beam column junction. So all the beam column junctions is your fixed support, and when the support is fixed and it takes the UDL load, then the equation of fix and moment is WL square by 12. Now whenever you have to move from left to right, your moment is negative because it is like this. Okay, so this sign is anti-clockwise and this sign is clockwise. So your left to right is anti-clockwise and right to left is clockwise. So your equation MFAB is minus WL square by 12. Now what is the value of W on that span? the value of W is 50.75. The value of L is 6 meter divided by 12. So students, after putting all this value, you will get your answer. MFAB is equal to 152.25 kilonewton into meter. Now, MFBA is right to left. So it is already discussed that when you have to move from right to left, the equation is plus WL square by 12. Now, the value of W is remain same because we have to move on same beam. So the value of W is 50.75. The value of L is equal to 6 divided by 12. So your answer is plus 152.25 kilonewton into meter. Our second span is MFAB. So for MFAB, your equation is minus WL square by 12. So your minus W. Now what is the value of W? The value of W is 46.82. L is equal to 4 divided by 12. So after putting all this value, you will get your answer minus 62.42 kilonewton into meter. Next, MFCB. It means you have to move to right to left. And whenever you have to move to right to left, the equation is positive. So it is plus WL square by 12. So it is plus W. The value of W is 46.82 into L. L means 4 square divided by 12. So your answer is 62.42 kilonewton into meter. Now your last span is MFCD. So your value of MFCD equation is WL square by 12. So the value of W is 50.75. The value of L is equal to 6. Then the answer is minus 152.25 kilonewton into meter. And your last answer is MFDC. So your answer is plus 152.25 kilonewton into meter. So students, this is the revision of your semester 5 in which the one method is moment distribution method. After finding out the fixed end moment, next step is to find out distribution factor. It is denoted by DF. Now, what is the equation of distribution factor? The equation is K divided by summation of K. Now, what is K? K means the stiffness of the component. Okay, and there is two equation. If your far end is fixed, then the equation is 4EI upon L, and if your far end is simple, then your equation of K is 3EI upon L. And you can see that in this figure, all the junctions are fixed support, so there is no any hesitation about if your far end is simple, because if your all the support is fixed support, it means your nearer support as well as your far end is always a fixed support. Okay, so in this example, your far end is always a fixed end, so you have to prefer for 4EI upon L, in which 4 is always remain constant, because the equation of distribution factor is K upon summation of K. It means you have to summation of all this value 4EI by L plus 4EI by L plus 4EI by L divided by 4EI by L. So your 4 is always remain constant. Now second is E. E is modulus of elasticity. So the value of modulus of elasticity is 2 into 10 raised to 5. So the value of modulus of elasticity for the beam and the column is also remain same. So your 4 and E is destroyed. Okay. Now I is moment of inertia. So you can see that this is beam and this is column. Okay, so say for example, this is beam. So for beam, your size of beam is 230 cross 300 mm. So the moment of inertia equation is BD cube by 12, in which B is equal to 230 D cube. It means you have 2 cube of 300, which is the depth of beam, divided by 12. So students, after putting all this value, you will get your answer of I beam is equal to 517.5 into 10 raised to 6. Similarly, this AE and AI is your column, and your size of column is 300 cross 300. It means your B is also 300 and D is also 300. So after putting all this value, you will get your answer of I column is equal to 675 into 10 raised to 6 mm raised to 4. So this is the calculation of distribution factor. Now we have prepared for distribution factor table, and you can see that in this figure. This figure is a mirror image from here. If you have mirror image from here, you can see that this one is 6 meter, this is also 6 meter. The load is 50.75, then it is similarly 50.75. Then if you have to design for A and B, it is automatically designed for C and D in opposite direction. Say for example, if the moment at A is positive, then obviously the moment on D is negative, because your beam is stable beam. Okay, so however moment is generated over here as positive, it means however moment over here generated is negative. Okay, so now we are moving further to the distribution table. So this is the calculation that in all the end is fixed, in which 4 is constant, E is also constant. So our equation is remain as I upon L. Okay, so you can see that for from A, that is 3 joint. A joint, from A joint, that is 3 member, AB, AE and AI. So your AE is column. Now what is the moment of inertia for column? So it is 675 into 10 raised to 3, sorry 10 raised to 6 divided by L. Now you can see that L is length. So what is this length? This length is 3350. So students, after putting all this value, we will get our answer of AE is 2.01 into 10 raised to 5. Our second member is AB. Now AB is the beam. So your I beam is 517.5 into 10 raised to 6 divided by L. So your length is 6 meter. So it is 6000. So students, after putting all this value, your answer is 0.86 into 10 raised to 5. Third member is AI. It means AI is the column. So your moment of inertia is remain 675 into 10 raised to 6 divided by your length is also remain same. It means for all the columns, if your moment of inertia doesn't change and your length of all the columns is also remain same, then for all the columns you have to put your value 2.01 into 10 raised to 5. Okay, so this is the calculation of K. Next column is summation of K. It means you have to summation of AE, AB and AI. Then you will get your answer 4.88 into 10 raised to 5. And your last column is DF. DF means distribution factor. So your answer is K upon summation of K. It means 2.01 into 10 raised to 5 divided by 4.88 into 10 raised to 5. So you will get your answer 0.412. There is some typing mistake. It is 0.412. Okay. 0.86 into 10 raised to 5 divided by this. So you will get your answer 0.176. Similarly, this divided by this like this divided by this, so you will get your answer 0.412. Okay, so this is the end for joint A. Now for joint B, so you can see that from joint B there is four member BF, BA, BC and BJ. Now your calculation of BA is remain same for BAB, but the only change is the final, because you can see that for AB it is 0.86 into 10 raised to 5, so over here it is 0.86 into 10 raised to 5. Okay, for BF and BJ it is column, so the answer is 2.01 into 10 raised to 5. Now the only change is in BC. Now for BC it is beam, so it is 517.5 into 10 raised to 6 divided by L. L means 4 meter over here. Okay. So students, after putting all this value, we will get our all this answer, and after that we have to summation of all this value. So it is 6.17 into 10 raised to 5, and after calculating the summation of k, the next step is to find out df. Df means distribution factor. So it is this divided by this, so your answer is 0.325. So students, this is the end of your step number 3, and all the calculations is remain same for all the examples. So this is the end of your step number 3, as well as this is the end of your today's session. Thank you.